Amar, make yourself visible.
Yes, sir. Is it visible, sir?
Yes.
Yes.
So Amar, you want some snap for IC engine?
Yes, sir.
NPCIL के लिए ना?
Yes, sir.
Okay, Amar. So let's start your IC engine snap. As you mentioned, you are preparing for NPCIL.
Yes, sir.
Okay. So my first question is to you, Amar. What is IC engine? What is the difference between IC and EC engine?
The basic difference between an IC engine and EC engine is that in IC engines, the the chamber, the combustion chamber that is inside the cylinder or the piston we call, where the burning of fuel takes place, and that heat will utilize in our cycles. That is a EC engine and IC engine. And EC engine, the combustion chamber is outside the cycle.
So open cycle gas turbine is a IC engine or EC engine?
Open cycle gas turbine.
Yes.
Open cycle gas turbine. Open cycle gas turbine. Gas turbine, sir. It's a IC engine, sir. IC engine.
Gas turbine is IC engine. Both
Open cycle. Open cycle gas turbine. No. Open cycle gas turbine is a IC engine. But
closed cycle?
Closed cycle gas turbine. Sir, closed cycle, I think closed cycle will be EC engine only, because in the heat exchangers we are exchanging the heats from the fuel gas to our.
Fine. So open cycle gas turbine is an IC engine.
Yes, sir. Yes, sir.
On which cycle it works?
Open cycle, it's
a standard cycle. Standard cycle for open cycle gas turbine.
Joule cycle.
Okay. What are the various processes in that, Amar?
Sir, it is same as closed cycle, but the basic difference is that in closed cycle we have a condenser or anything like that for the heat rejection, but in open cycle we simply reject it to the atmosphere, sir.
So can you tell me the all four processes which are there in open cycle gas turbine?
Open cycle. Sir, withdraw I can.
You can draw the PV diagram or TS diagram, anyone which you like.
Yes, sir. Sir, in and out, input, output. Sir, it is the input. First, it will take that air from the atmosphere air. It will compressed, and there will be isentropic compression will be there. That will increase its pressure and temperature. After that, it will goes for a heat supplied. Constant pressure heat supplied is there. After that, it's the expansion process, and again after expansion it will again pass to the air, atmospheric air. It is in, it is out to the atmospheric air.
Okay. So Amar, if you will compare gas turbine with the typical petrol engine.
Gas turbine with typical petrol engine. Okay. Yes, sir.
Which one is more efficient and why?
Okay. Gas turbine and petrol engine. 1 second, sir. Just sir, the efficiency of the gas turbine. Sir, efficiency of the petrol engine will be more, sir, as compared to gas turbine, sir.
Why you are thinking like this?
Sir, because in gas turbine, basically the work net which we are calculating from gas turbine is based on two things. One is work output, that is from the expansion process, and work input, what we are inputting. So in gas turbine, the work input value will be very much high because the states of the fluid which we are using here is a gas. So net work output will be less because the work done by the compression which we required work input will be more in gas turbine. So W net will be less in case of gas turbine as compared to petrol engine.
But W compression is required in ICE engine also, petrol engine.
And so the second thing is the mean temperature heat addition. Mean temperature during heat addition is more in case of petrol engine as compared to gas turbine, sir.
Okay. Can you tell me some of the advantages of ICE engine over EC engine?
Uh, yes, sir. Yes, sir. Basically, as we know that I've already mentioned that the IC engine and EC engine have the basic difference that compression chamber which you are using in internal IC engines is inside the cycle, and in the external and EC engine it will be external. So when the losses, the chance of loss of the heat energy or the heat supplied that we can use is more in case of EC engines, sir. So that's why in terms of efficiency, the IC engine is more efficient than AC engine, sir. And also I know some 2-3 extra points about this. Basically, in the IC engines are generally is applicable for the mobile components. That means for vehicles, for bikes. In that cases, IC engines are generally suitable. But in case of EC engines, although EC engines they required a very more space, they required very less more floor area required, a very bulking that equipment just simplification there. So that's why EC engines are unsuitable for the mobile type of application, mobile type of applications.
Amar, can you tell me something about the abnormal combustion in petrol engine? What do you understand by abnormal combustion? How it takes place?
Abnormal combustion in
Petrol engine.
petrol engines.
Yes, yes.
Abnormal combustion. Abnormal combustion basically refers to the I think refers to the pre-ignition, sir. Pre-ignition of a in a piston cylinder arrangement when the compression will going on, because the mechanism in petrol engine is that in one valve we'll have a mixture of that air and fuel, and after compression we'll start a spark, and where the energy is generated, where you can further use that. So I think abnormal combustion means while we are compressing and sparking is there, so in other sides also there will be a pre-ignition, the chances of pre-ignition is also there. I think it is refers to abnormal combustion in petrol engine.
So how we can decrease this chances of abnormal combustion or knocking in petrol engine? What factors you need to control? Like if you want to decrease the knocking tendency.
Yes, sir. So basically, sir, basically I think, sir, the fuels which we are using I think we should use that kind of fuel which have a good octane number, sir, very high octane number. So with that, if high octane number fuels, if you will use that, so what you will do, it will causes a exothermic reactions there, and from there the unburned fuel or anything we can that exothermic reaction will help to burn that extra or the extract, and from there we can minimize this abnormal combustion before compression, because at the time of compression we'll actually need this. So
what you will do? Just tell me some important points which you need to control actually, Amar.
Okay. Basically, sir, although the mechanism of petrol engine says that with after that proper compression we'll have a spark plug or spark ignition, and from where we'll will extract the energy in a better manner. So if we're talking about the abnormal combustion, so to minimize its effect, I think the first point is we use the fuel that has a very good octane number value first, and second, the equipments which you are using, that means the piston cylinder arrangements, their temperature should not be very much high, because sometimes overheating of the parts. So we should have ensure that before compression, the side parts, the piston cylinder arrangement, that should not be very much heat. So if it will exceed that value, so it will can again it will start burning before compression has been completed. So
or how supercharging is going to affect that knocking in petrol engine? What do you understand by supercharging?
yes, sir. Basically, sir, superchargers are generally we used when we required that mixing of our fuel or anything during our compression in a very good density. Well, as per the formula P equal to rho RT. So we required a very good density uh, at a time the mix during mixing in the compression chamber. So the superchargers they help to minimize that compress the air. It will compress and minimize the volume, and it will automatically help to improve the density of the mixing fuel air when we are using in compression chamber. So it will it will help.
So
It
what's
will
the
help
effect?
because one point I want to add that in superchargers they will definitely help to decrease the ignition delay, sir. Ignition delay tendency they will help to decrease, sir. So
So ignition delay will decrease, so knocking will decrease or increase in petrol?
obviously, sir, obviously, sir, if the ignition delay will be less, so the chances of detonation or the chances of that re-ignition will be less, no, sir. In the detonation will be less
In,
chances of detonation.
in petrol or diesel? In both.
Uh, Sir, I think in both cases, sir, in both cases, I think ignition delay we have to decrease, sir, so that the detonation
Achha,
or
you
knocking
decrease
will
the
not
ignition
happen.
delay, means the charge means the fuel will auto ignite quicker. So
Uh,
if it is auto igniting,
yes,
then
sir.
that is abnormal combustion in petrol engine.
No, sir. I want to just add on in a graph that see, sir. It is suppose it is the sir. It is the first point of charge where we just spark plug or just
Okay.
yes, sir.
Amar,
So
actually, you are mixing auto ignition with the delay period. Auto ignition petrol engine delay period. Delay period is a phenomena like that term is actually related to knocking or auto ignition in knocking or detonation in diesel engine. So you want to rectify it? You want to improve it? Whatever you mentioned earlier.
wait, sir, I can't get this. What else, really?
You mentioned that knocking tendency decreases
Yes, sir.
with supercharging in petrol engine. But at the same time, you mentioned if the charge temperature, engine temperature is increasing, that increases the knocking tendency. Both terms are actually different.
Okay, okay, sir.
Okay, okay. My last question is to you, Amar. What is Morse test?
Sir,
What is
Morse
Morse?
test. Oh,
Morse?
okay. Morse test is basically the test that is used to calculate to determine the value of the indicated power, sir.
Yes.
Indicated power, sir. To calculate the indicated power.
अच्छा कैसे हम करते हैं? How we conduct the Morse test?
Sir, basically, suppose there are number of 4 cylinders we are using in a Morse test.
Morse cylinder, what? Diesel engine, petrol engine, or anyone?
Sir, Morse test indicated power, to sir, I think petrol engine. I think we will use.
Mm-hmm.
So in 4 cylinders, we'll have the particular value of the brake powers of the 4 cylinders. So from there we have an overall overall value of that. When we subtract from that subsequent values of the cylinders from that overall one value, while subtraction in every cylinders we will get a value. So when we'll summation all this value, we will get the actual indicated power from that Morse test. So from that we can calculate the mechanical efficiency and this kind of stuff.
ठीक है अमर. I think now I can provide you the feedback.
Yes, sir.
देखो ICEC तो आपने ठीक आंसर किया था, बट आपको थोड़ा और क्लियरिटी होना चाहिए. IC का मतलब क्या होता है सर? व्हेन द फ्लूइड in which we are carrying out the combustion, the same fluid is expanding. That is known as IC engine. If you are carrying out combustion in some other fluid, and that heat generated by the combustion, you are transferring to some other fluid, secondary fluid, and that secondary fluid is further expanding. That is known known as EC engine, external combustion engine. जैसे EC engine में हम क्या करते हैं, we carry out combustion of coil. So air
Yes, sir.
आपका क्या है, ये जो flue gases हैं, flue gases are your primary fluid, but those are not expanding into the turbine. What is
No,
it?
no.
That steam is expanded. Because
In
steam,
heat exchanger, they will pass the flue gases, pass from the heat to the water or anything. They
yes.
will form steam, and
So
from that
they are what that kind of heat engine is what external combustion. Similarly, in closed cycle gas turbine, what we are doing, we are carrying out the combustion, but the heat
Yes,
generated by the combustion is utilized to heat some other gas, maybe some kind of monatomic gas which are having some superior properties.
Yes.
And
Sir, I
that
know this.
gas,
Oh,
that
actually,
gas
you are telling ki the definition should be like this. Ki it will touch this time this kind of words.
आप clearly बता नहीं पा रहे थे, आप confusion था आपको, like why IC, like gas turbine, open cycle gas turbine is IC engine और closed cycle gas turbine is IC engine. ठीक है, तो बहुत टाइम लिया आपने उसको बताने के लिए. बाकी डिफरेंस मैंने आपसे पूछा था आईसी का और ईसी का, वो आप बता नहीं पाए ज्यादा डिफरेंसेस आईसी और ईसी इंजन.
IC engine, EC engine, sir. IC engine, EC engine, sir. 4-5 points I know, sir, about actually. In terms of efficiency, if I will say IC engine is more efficient than EC engines because of the, I told na, because of the heat losses, chances of heat losses in case of EC engine is more than IC engine. So that's why efficiency.
थोड़ा सा क्लियरिटी के साथ बताना है, ठीक है
सर. जनरली कि अगर जैसे कि आप जैसे जो आईसी और ईसी का जो डिफरेंस पूछ रहे हैं, तो जनरली क्या 2-3-4 पॉइंट ही मतलब कैरेक्टरिस्टिक, जैसे कि इस पॉइंट के बेसिस पे ये उनका डिफरेंस ये है. तो सर उस पॉइंट में क्या क्या इंक्लूड होना चाहिए, जैसे कि एक एफिशिएंसी का वर्ड इंक्लूड हो गया, एक डेफिनेशन उसका इंक्लूड हो गया. दो
एफिशिएंसी का है, व्हाट काइंड ऑफ फ्यूल इज रिक्वायर्ड इन आईसी इंजन, ठीक है, उनका डिजाइन की बात आप कर सकते हो, मेंटेनेंस की आप बात कर सकते हो, देयर आर सो मेनी फैक्टर्स यू कैन मेंशन. ठीक है,
ओके सर.
तो आई आस्क्ड यू अबाउट abnormal combustion. Abnormal combustion तो आपने ठीक डिफाइन किया, abnormal combustion in petrol engine. Abnormal combustion in petrol engine takes place due to the auto ignition.
Yes.
Auto ignition of the end charge. वो ठीक बताया आपने. But end charge तो auto ignition कब बढ़ जाएगा? If you are using high compression ratio, if your engine temperature is higher, the fuel which you are using that is having lower octane number, तो auto ignition के chances क्या हो जाएंगे? बढ़ जाएंगे. Same if you are using supercharging, that will increase the knocking tendency. Why? Because supercharging करोगे तो आप एयर को कंप्रेस करोगे तो उसका टेम्परेचर प्रेशर विल इंक्रीज.
यस सर.
टेम्परेचर प्रेशर बढ़ेगा तो ऑटो इग्निशन टेंडेंसी क्या हो जाएगी? इट विल इंक्रीज. तो पेट्रोल इंजन में तो नॉकिंग टेंडेंसी बढ़ जाती है, बट डीजल इंजन में नॉकिंग टेंडेंसी क्या हो जाती है? घट जाती है. बिकॉज इन डीजल इंजन डिले पीरियड क्या हो जाता है? घट जाता है. इफ यू आर यूजिंग टर्बो चार्जिंग और सुपर चार्जिंग इन डीजल इंजन, दैट डिक्रीजेस द डिले पीरियड, एंड ड्यू टू डिक्रीज इन डिले पीरियड what will happen? The knocking tendency decreases. Diesel engine knocking takes place due to the charge. अगर auto ignition हो रहा है पेट्रोल डीजल में, that is normal combustion. Auto ignition of the charge is normal, but auto ignition is, if it is not taking place, that is knocking. Auto ignition नहीं होगा तो मतलब चार्ज क्या होता रहेगा? Accumulate होता रहेगा. Accumulate होगा तो then it will ignite. That is knocking in diesel.
तो सर जो ऑटो इग्निशन, ये जो प्री इग्निशन का जो फेनोमेनन है, वो तो जनरली हमेशा एसआई इंजन में ही होता है, सीआई में तो होता नहीं है, क्योंकि प्री इग्निशन कॉन्सेप्ट है.
यस सीआई इंजन में क्या होगा? एक्यूमुलेशन होगा चार्ज.
बिल्कुल, क्योंकि उसका मैकेनिज्म ही वैसा है कि सीआई इंजन में
वहां पे आपने उसको दोनों के लिए बोल दिया ना कि सुपर चार्जिंग से दोनों में नॉकिंग टेंडेंसी कम हो जाएगी.
हाँ सर, आप जब पॉज करके ब्रेक लिया, मेरे दिमाग में आया कि मैं दोनों को कैसे बोल सकता हूँ, क्योंकि दोनों का फेनोमेनन एग्जैक्टली अलग है. जैसे कि सीआई के लिए अगर प्रेशर टेम्परेचर जितना ज्यादा होता है, उनका नॉकिंग टेंडेंसी उतना कम होता है. लेकिन पेट्रोल के लिए एग्जैक्टली उसका उल्टा हो जाता है.
तो सुपर चार्जिंग से क्या होगा? पेट्रोल में तो नॉकिंग टेंडेंसी बढ़ेगी, डीजल में कम हो जाएगी.
डीजल में तो कम होगी, डीजल में तो डेंसिटी बढ़ता है, कम ही होता है.
क्लियर रखना है, ठीक है.
यस सर.
मोस्ट टेस्ट हम कंडक्ट करते हैं मल्टी सिलेंडर इंजन पे, वेदर इट इज पेट्रोल और डीजल. मल्टी सिलेंडर पेट्रोल इंजन, मल्टी सिलेंडर इंजन की अगर अपने को आईपी निकालना है, for that we conduct Morse test. क्या करेंगे? पहले सर चारों सिलेंडर को वर्क करेंगे, so we will measure the BP of the entire engine. Then sir we will turn off one cylinder. एक सिलेंडर को बंद कर देंगे. बंद कैसे करेंगे सर? Suppose we will cut the power supply, ignition कट कर देंगे उसमें, या हम क्या करेंगे उस सिलेंडर में? Suppose we will restrict the entry of the fuel. Diesel engine we will restrict the entry of fuel in first one cylinder, and in petrol engine we will restrict the power supply. तो एक इंजन को हमने कट कर दिया, एक सिलेंडर को हमने क्या कर दिया, कट कर दिया. नाउ ऑल थ्री सिलेंडर विल ऑपरेट, रिमेनिंग ऑल थ्री सिलेंडर विल ऑपरेट इफ विल टेक एग्जांपल ऑफ ए 4 सिलेंडर इंजन. एक बार हमने बीपी टोटल मेजर किया एंड देन वी मेजर द बीपी ऑफ सिलेंडर 2 3 4 एंड द डिफरेंस ऑफ दीस टू विल गिव अस द आईपी ऑफ सिलेंडर 1. Similarly, we will get the IP of 2, then IP of 3, then IP of 4, and then we will have the IP of the entire cylinder engine. ठीक है. तो इसमें कुछ assumptions भी होती है, वो भी आपसे पूछ सकता है कि फ्रिक्शन पावर जो है वो आपका चेंज नहीं हो रही है. The friction power is not changing. ठीक है. When you are even all cylinders are operating or like एक को आपने कट कर दिया. तो बहुत सारी चीजें हैं इसमें अमर जो आपको थोड़ा सा देखना चाहिए. There are some tests we conduct on IC इंजन. बाकी ठीक है, बाकी क्वेश्चन तो आपने आंसर कर दिए थे. थोड़ा सा
सर एक्चुअली हो रहा है.
ठीक है, ठीक है अमर, बाकी ठीक है, ऐसा दिक्कत नहीं है. अभी थोड़ा और रिवाइज करो एंड अगेन. ओके अमर.
ओके सर, थैंक यू सर.
ओके अमर, गुड लक.